Okay, today we got a Honda Element with a cooling fan issue. Let's see if we can get it fixed. Alright, this is what we're working on today, a 2003 Honda Element. Now I recently did a cooling system service on this, and when I was doing the service I noticed one of these fans wasn't working, this one right here. And so that's what we need to find out. Why is this fan not working? Now I actually filmed the coolant service that I did on this, and so if the video came out okay and it's actually up on YouTube, I'll put a link to it. Alright, now if we look down in there, hopefully you can see them both, but there are two cooling fans on this model because it has AC. If yours does not have AC, you're not going to have this fan over here because that's our AC condenser fan, and then the larger fan over there is going to be our radiator cooling fan. So the radiator cooling fans are typically larger, the AC condenser fans are typically going to be a little smaller on these Hondas. And just to round out the rest of the components that control these fans, just so we know what we're dealing with, we have our engine control module, or ECM, that's our engine computer. It's located on this model behind the glove box inside. And then we have two relays in here that control, one for each fan. In fact, let's just pull this box off and check it out. Come on. Doesn't want to cooperate. Alright, these two relays right here control our fans. This is going to be our radiator fan relay and our AC condenser fan relay. So they're right in line with how the fans line up in here. And of course I already pointed out the radiator fan, the condenser fan, and then we have a switch. I don't know if you can see it. Let me see if I can get a shot. It's a gray connector all the way down at the bottom. And that's going to turn our fans on and off when it gets about 196, so roughly 200 degrees. It's going to turn our fans on. Right there, that gray connector right there connects to the switch right in the bottom of the radiator. Alright, now that we know where everything is located, if you didn't watch that other video, or it didn't make it to YouTube, I'll show you what's going on. And we can cheat a little bit. We don't even need a fancy scan tool or anything. We're just going to turn our blower motor on, and well, the AC is already activated, so we'll just go out and look at the fans. And can you see? Yeah, maybe you can't. Let me get on the other side here. Alright, so you can see that fan is not running, and it should be running with the AC on, because it's an AC condenser fan, so it for sure runs when the AC is running. And then our cooling fan for the radiator is actually running, so that one's working, and that one isn't. Alright, now that you saw what our issue is and where everything's located, I pulled up a wiring diagram so we can know what we're dealing with. It's important to know how our system operates and how everything is laid out so that we can better troubleshoot it. Alright, so let's look at a few things. Well, here's our engine computer, or ECM, that's represented here. Here's our radiator fan motor. Here's our AC condenser fan motor. And here's the radiator fan relay and our AC condenser fan relay. So that's kind of our layout right here on this system. Now I'll go over both sides, but really I'm only concerned with our AC condenser fan side because that's the side that's not working. But the best way to do it, we'll just follow the power in. So here we have a fuse here and a fuse here, and that's feeding our two relays. So we just follow the power in, and you can see that this switch is normally open on both sides. So in order to close that switch, we need power on the other side of our relays. So that's our control side, and then this will be the load side doing all the work, in this case running the power to the fans. And so in order to activate these relays, we need to provide this side of the relay with a ground. You can see power comes in right here, and then it splits and comes over here. Whoops, moving around. But the power splits and feeds both sides of our control side on the relay. And these squiggly lines is a coil of wire. So when we have a ground on this side and a power on this side, which is how a relay works, energy will flow through those coils of wire and create a magnetic field. That magnetic field will close the contacts on each side. So that's how these relays are working. I have a video on troubleshooting these relays on Hondas. I'll put a link to that too. But in simple terms, we're just running power through a coil of wire, creating a magnetic field. That magnetic field just closes the metal switch. And by looking at this, you can see that we're connected right here and right here. The same ground is connecting both of these relays. So one ground is connecting both relays, and what that tells us is both of these fans run together. So no matter what, both of these fans should run at the same time. Now this is a pretty simple circuit. These fans have one speed. Newer systems have multiple speeds, or at least a high-low. This is an older system. We just have one speed, both fans either on or off. So it makes it a little easier troubleshooting. Now while we're right here, let's continue on with how these relays are activated. So if we follow this wire down, we see that it breaks off and goes this way, and that goes to our switch, and that's where I pointed out at the bottom of the radiator, and it's just a simple switch that just closes. Basically, once we hit close to 200 degrees, or in this case it says 196, but that's a rough estimate. It's roughly 196 to 200. That switch is going to close, and that's going to complete our circuit to ground. So that's going to provide these relays with a ground, which will close our switches, and then that provides power down to our motor on both of them. And then of course for our motors to work, we have to have a ground on each one. So that's the system when it's working with a radiator fan switch. Now if we follow this right here where it breaks off and goes to our engine control module or our engine computer, you can see we have fan control right there. And that's basically what I did on the car right now. When we turn that AC switch on and all of our inputs are correct, it's going to control this relay and turn the fans on. So as long as everything's working properly on our AC system, when we hit that AC button, it's going to ground these relays and turn the fans on, just like our switch does. So you can see that there's two ways for these fans to come on, either our radiator fan switch or our fan control. But in either case, both fans have to run. Now when I was servicing the coolant system, the radiator fan switch was closing because I left the AC off, and it was turning our radiator fan motor on, and that's when I noticed that this one wasn't coming on. So I know my switch is working, I know that this relay is working, and I know that this motor and power and ground, everything over here is working properly. What I don't know is if I have a good ground, if I have a good power, or bad fuse, or if I have a bad relay. So everything on this side I'm unsure of. This side I'm okay, because not only were we able to control this side with a radiator fan switch when I did my cooling system, but we also just verified it right now with our by pressing the AC. So I don't think there's any inputs problems coming up to these relays. Most likely either our problem is a relay or a bad motor. Okay, now because this condenser fan motor is easy to get to, we're going to go right to the component, which is typically what I like to do if I can get to it. We're going to unplug it, and in place of our motor, we're going to put our test light there, and we're going to see if when we turn the AC on, it lights our test light. If it does, then we know we got a bad motor. If it doesn't light it, well then we got to trace back up our circuit. Either we have a problem here or we have a problem with our ground. So let's go there first and see which way we need to go. Alright, this is what I'm going to use, my cheap little Harbor Freight test light that I have modified, and I soldered a little tip on the end which is just like the other tip, so it makes it easy for testing two-wire connections like this. We can just unplug it and then use these to touch in there on each side, and because our fan needs power and ground, once we make these two connections, then our light will have power and ground, and it should energize if we do have power and ground. What's nice about a test light is it doesn't matter if we get the power on this side and the ground over here or vice versa. Power flowing through this light bulb, it doesn't matter. It's going to still light it, so it doesn't matter which way we go. And seeing as the battery's right here, let's just verify that our test light works. You can see that it does. And what I was saying before, it doesn't matter if we switch it around, the test light is still going to light. So that's the beauty of a test light. It doesn't matter which way we go, it'll still light. Alright, now we'll just reach down in here and see if we can unplug it. Alright, it unplugged. Now, obviously this side goes to our fan. We don't need to test that side right now, but we are going to test this side. And so I'm going to take my two leads on my test light and I'm just going to touch it, one right there and one right there. You can see the two terminals inside there. Now, we don't want to spread them out by jamming our test lights down in there, because then the next time we connect it, it won't make good connection. So I'm just going to touch it right inside there, and we're going to go inside the vehicle, turn our AC on, and see if it lights. Now, it might be kind of hard to see, but all I'm going to do, You see how I have it here, just holding it like chopsticks? I'm just going to touch them in there after I turn it on. That's it. That's how simple this test is. Alright, I turned on the fans. Now we got to be careful. We got fans running. We don't want to get anything caught in here. You can see we're good. We got power coming to this fan. It needs a new fan. That'll be $100, please. Okay, as you saw, because our test light lit, we know we have power coming in. We have power coming in and we have ground, and our whole circuit is working. So we verified everything is working. We need a new condenser fan motor to fix this car. Now, what would I do if it did not light? Probably the next step, because I'm right there, I'd probably check and make sure, I'd look for ground right here. So the easiest way to do it is we need to hook our test lead, one lead to battery positive, and then hook the other one to this black wire right here and see if we have a ground, see if it lights our test light going straight to the battery. Alright, I'll show you how to do the test. I'm just going to continue to use the test light, but this time I'm going to use my OTC because it still has the clip on here. We'll just clip it to battery positive, just like that. We'll verify it works by touching the other side. Hopefully you can see that my test light is lit. And now we'll just go in here and verify that we have a ground on our black wire, which should be this top pin. And there we go. Hopefully you can see the light is lighting up. Can you see that? Yeah, I think you can see that. But we just verified. We knew already that our ground was good, but that also verifies it. And once again, I can't stress enough. I'm only touching the tip in there, which is why the light might flicker once in a while. We're not stuffing it in there. We don't want to create more damage. Now we verified our ground. Now you could do the same exact test to verify power. You would just connect your test light to battery negative, and then we would, this is the wire I just touched right now. We would just touch the other terminal right there. But in this case, in order to activate the system, we would have to turn the AC on. But that is kind of redundant because our test light would have shown if we had power. Once we verified ground, our test light would have lit if we had power. So that's kind of a redundant test, but it's one you could do. Now we verified our ground. Now if we didn't have power and we were trying to backtrace our circuit, we would want to go up here to fuse 1, or if we were on this side, we'd go to fuse 4. I'll go show you where this 30 amp and 20 amp fuses are in the car, and we can test them. Alright, back to our fuse box. Here's our condenser fan relay like I said before. Here is the 30 amp condenser fan fuse, this number 1 position right here. That feeds the load side here and goes down to our condenser fan. This 20 amp does the same thing, but it goes over to our cooling fan, our radiator cooling fan, and carries the load down to our cooling fan. So they both do the same thing, just one feeds this, one feeds this. And we can test them for power, and we'll continue to use our test light. You can see I have it connected to battery negative or ground. We can verify that we're good to go. It's lit up. Now all we have to do, you can see that there's little metal tabs, one right here, and that once we touch it, that means we have power on that side of the fuse. And we go to the other side, and it means we have power on that side. If we're missing power on one side, that means the fuse is blown. We can check this one too, power, power. So as you see, we're good all the way around. But yeah, if we're missing it on both, then we have an issue. If we're missing it on one side, then that means, well, there's also an issue, but that usually means that the fuse is blown or there's a connection issue right in there. Now, we checked the fan switch, we checked our controls by pressing the AC button. We know everything is working, we know we have power, we know we have ground. That would leave our relays, and so I have a whole video on testing relays, so I won't go too much in depth on this, but just suffice to say that once we pull the relay out, we would want to make sure that we had power coming in here. This one will have nothing, or actually we could potentially, as long as we didn't have an open there, we could hit ground on that. But generally what we want to see power on that number 2 pin, and we want to see power on this number 3 pin once we turn the key on and turn the AC on. And then we want to see ground over here on this side, and we can do all those checks with you could use a fancier tool like a power probe, or we could stick with the test light. And like I said, I'm not going to do it right now, but all these tests are the same. We either connect our test light to battery positive and we look for a ground, or we connect it to ground and look for a positive. But once you know how the system works, hey, we need power, we need a ground once we activate it, and we need full-time power coming in here, and we need a ground on this side to run our motor. Once you kind of know the layout, using a test light can definitely tell us which direction to go. Now, what if you don't want to do all that fancy schmancy relay testing? Well, I already pointed out where our relays are, and if you look at the part numbers, you can see these are all the same relays. 1, 2, 3, 4, and 5. So we got 5 relays in here that are all the same. We can just simply pull the relay out, the one we suspect is going bad, and swap it with another one. Now, the easiest way to do it would be swap the 2 cooling fan relays. We could pop one out, put it here, and put this one over here, and if all of a sudden our problem moves from one fan to the other, we found our issue. It's a bad relay. But if we move them and our problem stays the same, then we got to troubleshoot this circuit. Now, another test we can do on actually our fan and our relays is the old-fashioned tap test. We can bypass a lot of stuff, and we could just tap it. Now, you could use your finger, maybe use the back of a screwdriver and just tap it a little gently. We don't want to break our box or anything else, or if it's working, we don't want to break it. But we can just tap on it, tap on a relay with it energized. The best thing to do would be turn our system on and tap on it, and all of a sudden, if it comes on, we found a problem. It's usually a bad relay. Now, we always have to keep in the back of our head that our contacts in there may be bad, but typically when you just tap on it, it's a problem with the relay. Now, we can also do the same test with our motor. Each one, it doesn't matter which one. We can kind of just tap right here, and I think I'll do that. We'll see if we can get this thing to run. We'll just tap right there. I think I'll just use a long screwdriver. We'll just tap down in there and see if we can get it to run. Now, once again, we're going to be running our fans, and this potentially may come on, so we don't want to have any fingers in there, and we don't want to get our screwdriver jammed in there and hurt ourselves or break more things on the vehicle than we need to. So we definitely have to think about safety when we're sticking things in here when the fans are running. Alright, I got the system activated again. I plugged it back in. We'll take our long SK screwdriver, see if we can get it to run. Nope, this fan's dead. Sometimes that trick works, sometimes it doesn't. In fact, I showed it work on a Honda Civic, but this element, it's dead. Alright, I tried to keep this diagnostic video a little bit simpler. We just used a test light today and a couple of tap tests to see if we could find our problem, and we did. Now I need a fan. I got to get this thing fixed. In any event, if this video helped you out, you liked it, make sure to give it a thumbs up. Thanks for watching. Alright, how about some bonus footage using the old relay buddy? This is fun even if you don't have a problem. I popped the fuse out for our AC condenser fan. There it is right there. Now, this thing will open and close the circuit and test it 10 times. I think it's 10 or 11 times just to verify that it's working. Now, it doesn't put it under a load, at least I don't believe so, but it's an easy way to check it real quick. So we just need to find our appropriate area to plug it in. And this looks like one right here. If it wouldn't fit in there, I do have adapters. We need to make sure it's set to 4-pin, and then we press the button and it'll do its test. Can you hear it clicking? It's opening and closing that relay. That's the relay clicking. If it lights green, it's good. If it's red, it's bad. And green means it's good. So what we suspected, it's our fan that's the issue, it's not the relay. Hey, what are you guys doing here? You still here? Alright, I'll give you a couple more tips. How about some tips dealing with these fans, trying to get them out? Like many Hondas, they don't leave us enough room to bring it here. And there's a plastic cover here, and just pulling that plastic cover up, they still don't quite leave us enough room. So here's how I deal with it. And of course, I removed that plastic cover. The overflow tank, I pulled that off. Pulled it from the hose and popped the one 10mm bolt out. Of course, we have two 10s that hold this fan in, so you can see it's loose. You got to pull those out no matter what. And once we get that plastic cover off, which you're probably going to break the clips, I would definitely have clips. We got a bracket right here and a bracket right here that stabilize our radiator, so now we have some play on our radiator. That helps us out. Now what I do is I go down below and I pull the cover back. I peel it back and you can see it. I just take it down enough where I can get access, because this fan, there's a wire going to our AC compressor and it's clipped in a couple places, and you got to deal with it from down below. Trying to reach through here, very, very difficult. You can't see what you're doing. I don't recommend it. Now I'll show you in a second that fan, the connections down there. But when you're dealing with these, even disconnecting this and trying to pull it through here, it's still really tight. So what I recommend, pull these bolts right here for our brace, and right, where is it? There's a brace right here going down the middle. I don't know if you can see it. So brace going down the middle, and there's 110 down there, and I pulled that one. That, you know, with the cover down below, it helps us. And now we have plenty of room. We can lift this up and sneak the fan in and out. Let me go below, I'll show you those connectors. Okay, looking from down below, where is the wire? Here's the wire we have to disconnect. You can see I have it disconnected. So this clip right here, hopefully you can see it, but we got to squeeze those two tabs right here. You got to squeeze those in and push it out like that. And then over here, where's our gray connector? Can I get a light on it? Come on, help me out, light. Where is my gray connector? There it is right there. Hopefully you can see it. This connector is clipped onto the fan, so you just have to squeeze this tab right at the end there. You squeeze it and pop the whole thing right off the fan. You see it's not unplugged, it's just disconnected from that metal bracket. So it's definitely easier to pop this shield down, grab those, and then while you're here, let me show you, grab the 10mm bolt to this bracket right here at the end of my finger. This stupid light, I don't have any room. Alright, if my light would cooperate, here's the bracket right here at the end of my finger. I had to go with some extensions and come from that side and come across and over to pop the 10 out, but it's pretty easy. So once you unclip that, disconnect it from the fan right there, and then pop that 10 out, it makes it so much easier up top. And this bottom cover, it's just held in with clips, just like the piece of trim on the top. There are these little push clips, and they break. You can see all the carnage I have here. So it definitely helps to have extra clips, because especially down the bottom, you're going to break them. And there was also a bolt that's right here that holds it in, and it's just kind of clipped on the side with a couple of clips, and just pull it down, get it out of your way. Makes it so much easier to work. Alright, now with everything unclipped and this bracket loosened up, we should be able to just pull our fan straight out without doing any damage. Just like that. If you try to do it without loosening that, there's a good chance you're going to do some damage to your radiator or something else. Don't recommend it. Alright, looking at the bottom of our fan, these feet just sit in the bottom, so that's easy. Where Honda made it a little more difficult is pinning that wire here. So there's just that gray connector where you just press the tab and it'll slide right off this piece right here, and then this one, it slides through, so you got to squeeze it and then force it out. Once you do that from down below and loosen this, you saw you can pull it straight out. Alright, let's try to show you if the clip's back in place. There's that one right there, clipped into place. And if we can catch the gray one, there it is right there. And our bolt's back in place. I just got to tighten it up, and you can see how I have the socket with an extension going across, and then I'll put another extension on and use my ratchet over here. Alright, she's all put back together. There's a shot of the fan in place, plugged back in, everything's back connected. I should mention that I did unplug the alternator when I pulled this fan out, just so I wouldn't damage the connector. It's a good idea to do that. I suppose we should verify our fix, right? See if it works. Hopefully you can tell. Yeah, they're both working now. We're good to go on this vehicle. Unfortunately, I didn't have time to film the fix, but hey, hopefully these tips helped you out. Thanks for staying to the end. I think I need a new glove.